Hey guys, lesson 1.1 is modeling and equation solving. So we're going to spend the beginning of this lesson, or the beginning of these notes, talking about different types of models. Okay? All of which you've worked with in some way, shape, or form. So first one, well, general definition, mathematical model. A mathematical structure that approximates phenomena for the purpose of studying or predicting behavior. So whether we look at numerical, algebraic, graphical, we're going to look at all of these. The idea is you can use it to predict behavior. So the first type we're going to look at here is numerical model, the most basic kind of mathematical model in which numbers are analyzed to gain insights into phenomena. So what's going to be happening? So numerical model, guess what? You're given a table of numbers pretty much. This table shows the growth of the federal minimum hourly wage, which they refer to as MHW, from 1955 to 2015. The table also shows the minimum hourly wage adjusted to the purchasing power of $2015. Answer the following questions. So you have the table over there. In what 5-year period did the actual minimum hourly wage increase the most? Is that the biggest increases you guys scanned through down there?
Yeah.
I think a lot of the increases are pretty small, aren't they? I mean, back in 75, you have a $1 increase. But then from 2005 to 2010, did it go up, what, about $2? Okay. So 2005 to 2010. I don't think there's really need to explain because you can see it on the chart, right? In what year did a worker earning the minimum hourly wage enjoy the greatest purchasing power?
Is it 70?
I think I disagree with 65. 1970?
Yeah.
Oh, yeah.
Or so you're looking diagonal instead of straight across? Okay.
I thought they said 1975 for a second.
Oh, no.
And I was like, what?
Yeah. 1970, the purchasing power in 2015 dollars was 9.74. So 1970. Okay. And I don't have an official definition of purchasing powers in front of me, but I believe it has to do with how much you get for your dollar type thing. Okay. I don't know, any of you guys in econ might have more information. Maybe not yet. I don't know, but so. Okay. And C. A worker on minimum wage in 1980 was earning nearly twice as much as a worker on minimum wage in 1970. And yet there was great pressure to raise the minimum wage. Why? Yeah. If you go back there and look, what they give 70 and 80, it was $1.16 minimum wage and then $3.10 minimum wage. But during that same time span, as the minimum wage is going up, your purchasing power is going down. And if your purchasing power is going down, you're going to need more money to make ends meet, aren't you? Okay? So even though your hourly wage was increasing, the purchasing power was decreasing. You can write some kind of answer there, however you want to. I'm going to say purchasing power was decreasing. I'm going to go ahead and say even though minimum hourly wage was increasing. And I just used MHW for minimum hourly wage. Okay. Very basic there, right? Got to enjoy a few basic questions here. So just, again, looking at using the numbers, answering your questions. Okay, you ready for example 2? Example 2, I'm going to make you work a little bit. Got a new table. This one shows a fluctuation in the number of commissioned officers on active duty for several years from 1965 through 2015. Is the proportion of female officers increasing over time? So what's the trick to this question? What are they asking? Is the proportion of female officers. Is the number of female officers increasing? Yes, the number of female officers is clearly increasing. That's pretty straightforward. But does that mean the proportion of female officers is increasing? It doesn't have to. Could it still be? Yeah. What are we going to have to look at to figure this out? We're trying to figure out the proportion of female officers.
Like
Percents. Percents, what are we comparing here?
female to male? Or female to total?
I would have said female to total. Okay. So we're going to be comparing the females to the total. Now, what's that mean you're going to have to do?
Divide every female by the total female.
Okay. And based on what you know right now, the quickest thing to do is to plug those 10, 15 numbers in your calculator and do it. Now, hold off as you do that. I want to teach something on the calculator. That's going to take us longer in this instance because we don't know how to use it, but we have these options in our graphing calculators where we can enter a list of data, and then you just enter the function, like you enter what you want to happen once, and it will do the math for you. So, everyone make sure you have a graphing calculator at your desk. I probably should have practiced this morning to make sure I remember what I'm doing. But we're going to go with it. And I know, in all reality, some of you are saying, Mrs. Sargent, I already have this problem about done. I've just been sitting here dividing them. Okay. Now we've got to switch screens over here. Okay. There we go. Okay, did we all find our calculators? We ready to go with it? Okay, on these calculators, right over here, where you see your stat button, above the stat button, you also have something called list. Now, if I recall correctly, we're just going to go into stat, though. Yes. Okay, so right there, I pulled up that menu by just hitting stat. Is it good? Now, in here, notice there's some different options. We're going to go into number 1, which is edit. Did we have gotten here by going through the list? Possibly. Okay, now, I personally already have some numbers in my list from who knows whatever I was doing last time. So in order to clear the numbers, I don't know if you guys have numbers in your list or not, but if you do, we want to clear all those numbers out, yes? You can go through and individually delete each item, or if you need to clear an entire list, go up to the heading, so I'm up in L1, do not hit delete right now, or you will delete L1 in its entirety and L1 will cease to exist. But if you are up in the heading and you hit clear, enter, it will clear everything in the column. There's a way to get L1 back if you delete it entirely, but I don't remember how. So, okay, so let's put our numbers in. What numbers are we going to need in our list? Oh, we're going to need female, yes. So you're going to put your female numbers in one of your lists. You want to make that L1? And then what other numbers am I going to need? Your totals. So I'm going to put those in L2. Doesn't matter if you switch them, it's fine. Well, it'll all work out the same in the end. So get your numbers on there. You can just enter a number and or enter down, right? Doesn't hurt to make sure you've copied or, typed them all correctly. Do the same thing in L2 with the totals. I can at least feel confident I didn't skip any numbers because both my L1 and L2 columns have the same amount of numbers in them, yes? That's an easy check to at least try to ensure yourself that you're on the right track there. So, let's see. In the L1 column, I put all my female numbers, and this is, I'm not going to write all the numbers down, but we just put all of our female numbers, right? In L2, we put all of the totals. Now, L3 is where we're going to put our answers. Are you guys ready to talk about the next piece? Okay. So, in L3, I'm going to arrow over to L3. And the idea here is that I can do all these calculations at once. So I'm going to go up into my heading L3. So if you see there, I'm highlighted up in the heading of L3. And what I'm going to do is, what do we want to do to find these proportions? We said we wanted to do females divided by the total, yes? So in my heading of L3, I'm going to type in L1 divided by L2. Now, if you go down, look at your number pad. Do you see L1, L2, L3, so on and so forth? They are second functions of your numbers, right? So I'm going to do second L1 divided by second L2. And then, so notice it pops up right here. I did L1 divided by L2. Those are just second functions of 1 and 2. Hit enter, and you get all your answers in one fell swoop.
Whoa.
So it does.
Wait.
Okay.
How'd you do the L1?
L1 is the second function of number 1.
Oh.
It's right above the 1 button.
Oh, I see it.
And that's okay. And what I was just going to say is, so this is the decimal form of the percentage, yes? Do you want the actual forms of do you want the actual percents? So options. Caitlin just mentioned is that she went into L4 and said L3 times 100. Or could I have done L1 divided by L2 in parentheses and said times 100 right there? You can. So you have some options there, don't you?
Mine's not letting me.
Okay, I will. Now, and I used L1 and L2 because that's where my values were, right? Obviously, if your values were in different lists, you'd have to do something else, but I kind of like Caitlin's idea. She went over here and said L3 times 100. That just moved them all to percents, right? Okay. Now you go back and answer the question. What do you mean yours isn't left here? Okay, did you go up in here where the L3 heading is? You did second L1.
No, I didn't hit second.
And then divided by, notice L2 right here is the second function. So second L2.
There we go.
Okay. Okay. So, right here, like if I look at my L3 column, I have 0.0, oh wait, you know what? I didn't write down. Okay, well L3 was L1 divided by L2, yes? So if I round it, I had 0.039. Okay. 0.042, 0.056, 0.082, 0.106. I'm just writing these down so I have them in the notes. 0.132, 0.151, and hopefully these are matching up. 0.152, 0.159, 0.177, and what is that, 190, I think is what I've written. Okay. And any of those, if you'd rather have written percents, move that decimal to right, and that's what? 3.9%, right? You can write them all as percents if you want. Now, what's the answer to our question?
Yes.
Is the proportion increasing?
Yes.
That's a solid increase, isn't it?
It
Okay.
is.
And so I'm just going to say yes, and I'm going to just say as shown in L3, because that's where I put my supporting data. Okay. Now, in all honesty, some of you are thinking, okay, the time it took me to just go through and divide all those on the calculator was still quicker than entering all the numbers, right? But where can list come in handy? If you have multiple things you have to do, okay, it gives you all the data at once, okay? So now if I needed to do something else with the females and the totals, or I could also add a male column, okay, we can do that, okay? Questions there? Okay. So that's the idea of how to use a numerical model. We'll come back and revisit the idea of using list a little bit more when we get to a graphical model. Now, before I turn my page, algebraic models. So by definition, a mathematical model that uses formulas to relate variable quantities associated with the phenomena being studied. It can then generate numerical values of unknown quantities by relating them to known quantities. So we have a couple algebraic we're going to do here. Well, we have one algebraic, and then we'll talk about graphical and do a little bit of both there. A pizzeria sells a rectangular 18-inch by 24-inch pizza for the same price as its large round pizza, which has a 24-inch diameter. If both pizzas are of the same thickness, which option gives you more pizza for the money? Where's your better buy? That's what we're asking here. Thoughts on how I can find my better buy?
An area of
Would area tell me where I'm getting more pizza for my money? Okay. Now, they told us that the pizzas are the same thickness, so we don't have to worry about volume. Okay, because thick crust versus thin crust, that's kind of a different amount of pizza in a way, isn't it? Okay. So we're going to talk about area. So what do you know about area of the rectangular pizza?
This is 18.
Yeah, it's a rectangle. Length times width. 18 by 24, right? So what is 18 times 24? I forget. It's 400 something, I think.
What do we get out of it? Yeah.
Oh, are we stuck in it? So, okay, my answer always when I'm stuck in something is how do I get out of it? Is I do a second quit. So right here above mode, you have quit. Anytime I'm stuck in something, I'm like, okay, I need out of there. That's what I usually do. Does that work for you?
It's 432.
Okay. There you go. That can work too. Although I don't know, as I turned mine back on, it was still in there, so. Okay, yeah. The second quit is what I do. There's probably other ways, but. Okay, so now you said 432? If I want to get official, 432 what? Or did someone say this? Inches square? Okay, there's my rectangular pizza. What's the other option? We have a,
Why'd you put cube? Yeah, that's square.
squared.
I got no answer. Did I say squared at least?
Yes.
Yeah.
Okay, I just wrote the wrong thing. Yeah, I got no answer. Okay. What about a round pizza?
Radius squared. Was
Okay.
that actually right?
Pi r squared.
Oh, okay, well I was close enough.
You would get it together.
So,
Great
5
job, Caitlin.
times 12 squared.
Pi times 12 squared then?
Personally, I'm a last
That was a shot in the dark, I'll be honest.
Okay. So if they give us the diameter of 24, we are smart cookies and we know the radius is 12. Or we take a guess and we get lucky. I don't know.
452.3893421.
Okay.
That's the bang for your buck.
Does everyone get the same exact answer? So did you guys type 3.14 or did you use the pi button? Okay, so that's why I have a different answer written down. If you type in 3.14, you get a slightly different answer, yes? Not enough to make a difference, but
The division.
so, yeah, did you guys find the pi button?
It's the second to the carrot.
Yeah, it's the second function of the exponent caret. So,
The carrot, do you remember?
452.39. Yeah.
Okay.
and that officially is also inches squared with a 2.
Yep,
I got myself this time. Okay, what's the answer to the question?
round.
Okay,
Is that
Katie's in luck. The round pizza gives her more pizza for her money, so she's safe. Okay.
Is that a big pizza? I feel like a 430 inch pizza is like, you know.
Well, which one was the,
Area.
that's 18 by 24.
That's a 2-foot pizza.
That's
Yeah.
that's 2 rulers.
Well, and here's what I'll say. If we're comparing, because it's very similar to a 24-inch diameter, usually, no, 24-inch would be a big pizza. Because a lot of large pizzas are more like maybe 16 is what I was thinking. Maybe 18. So this is like one of those super big
Friends
monster
and
pizza or something.
She wants a debate
So.
party.
Chicago deep.
Okay. Regardless,
pizza.
the round pizza gives you more bang for your buck in this situation.
So, and we like the bang for our bucks.
Okay. Yes, I'm thinking about a 2-foot pizza. That's a little bit bigger than the traditional rectangular pizza too. Okay. Now, that takes us to graphical models. Okay. And we're actually going to look at graphical and algebraic on this next one. But graphical model is a mathematical model that gives a visual representation of a numerical model, or an algebraic model that gives insight into the relationships between variable quantities. Excuse me. So we're going to kind of look at them together. Now, we're going to start talking about Galileo. If we don't get done talking about Galileo today, we'll talk about Galileo more tomorrow.
Whoop, whoop. Galileo.
Okay, so Galileo spent a good deal of time rolling balls down inclined planes, carefully recording the distance they traveled as a function of elapsed time. His experiments are commonly repeated in physics classes today. So it is to reproduce a typical table of Galilean data. I think I have a typo there. Because it didn't sound right to me as I read it, but okay. So we have a table of data here. Okay. We're being asked 2 questions. We're going to talk about what graphical model fits this data, and we're going to find an algebraic model to fit this data. Now, graphical model. Let's start there. As we talk about a graphical model, I basically am trying to ask you, what does this graph look like? What's the shape of this graph?
Rectangle.
We're not talking about the pizza anymore.
No, it's
Is that not the shape of the graph?
The graph. This is a table.
Oh.
Like if we,
graph.
the graph. In other words, if I took this data and put it on
Oh.
a graph, like an XY,
Guys,
Because
What's
it's
that?
increasing by like.
so some kind of increasing function,
yes.
it's going to be moving up. What shape is it going to be moving up in?
I'm
not
The diagonal kind.
Is it nicely linear?
Yeah, I think so.
So my slope is the same all the way along here?
No, it's not.
Okay.
It's gonna be a scat.
So, what did you say, Autumn?
We should plug in the calculator.
Yes, we're going to plug it into the calculator. Now, here's the deal. I don't have an equation to plug into the calculator right now, do I?
No.
But that's later. We're going to plug the points into the calculator. We're going to learn right now how we plug the points into the calculator. So, you know where we're just in list?
Yes.
Yeah.
Okay, get back in list.
Oh.
Like actually list or stat.
Okay, so list, you can go in this way. I'm trying to think. Yeah, I like to go into stat better.
Wait.
So, just hit the stat button.
Clear.
And then when you hit the stat button, you get this menu, and number 1 says edit, yes? And then you can just go into all the lists. Now, to clear an entire list of numbers, clear enter in the heading.
Press the-
If you're deleting individual entries, you can delete individual numbers, but if you don't delete an entire column, it's annoying, okay? So I'm going to go up to L4, clear, enter. I'm going to go up to L3, clear, enter. L2, clear, enter. L1, clear, enter. Okay, so with this in mind, we have elapsed time, we have distance traveled, yes? So I'm going to put my time into L1. I'm going to put my distance traveled into L2. L1 will be easy. It's 0 through 8, isn't it?
Yes.
0.75.
Okay, totally.
Oh, I'm on a roll here.
Okay. Oh my goodness. 0 through 8. Now, type the corresponding y values in the next one.
Can you just press graph out of this?
Not exactly.
Oh.
Of course you can.
So you gotta hit 5 other buttons.
And second it.
Not 5. I don't think. Okay. So, your job is to get your numbers into your list. Are we there?
Yep.
Okay. So, what we use to graph these is we use something called stat plot. Okay. Now, some of you have had issues where your stat plot was turned on and it caused a problem, didn't it? Okay. So, first thing I have us do is we're going to go up and look where we can change our settings. So, above the y equals is stat plot, yes? So I can go second, stat plot. And right there is where I can change some settings. So like if you notice, right now, all my plots are off, aren't they? Okay. Plot 1 uses L1 and L2 as my variables. Plot 2, actually they all do. But we can change that. So like right now, if I hit enter and go into 1, okay, well I can change what I want here. First of all, I can change it from on to off.
How do you change the color? Oh, that's.
Okay, I can change the type, which I just want the first one, which is the dots, but I can get fancy and do some of this other stuff. Here's the important part. Your X list should be wherever you put your time values. Your Y list should be wherever you put your distance. So mine is L1 and L2. I can change what piece is going to show up, what marking is going to show up on my graph, and if you want to get fancy, you can change the color. Now, importantly, did you change your graph to on?
Yep.
Okay.
Magenta.
Okay. Now, we're gonna hit graph. Oh shoot. Okay, why did a parabola randomly show up on mine?
Because you have another one.
So here's where I go into my y equals, and I'm gonna clear out what I have in y equals. So my y equals screen is blank, or turn it off. I'm gonna go back to graph.
Hard to see. No.
Now, are all of my points showing?
No.
No. I'm in Zoom 6 probably, which is a standard screen, but they're not all showing. Could I change them so they show?
Probably.
Because I should have 9 dots and I don't have
Mine's
9.
not letting me turn it on.
Okay, we'll look at that here in a moment. Now, so what I would suggest is you go into your window and think about changing some settings. Like, do I need to see the negatives?
No.
No, I don't need -10 as mins. And think about how big we have to go on the X. It would be good to go 10, right? But how high do I have to go on the Y's?
Probably real big.
Like
48.
So if you hit
48.
and then just hit enter while it's flashing there. Now it should be on.
Oh, okay.
Wait, how do you
Okay.
on the minimum line?
So my X min I'm gonna say is 0. My X max I'm gonna leave as 10.
Graph.
My Y min 0. Oh crud. Y max I'm gonna say 50.
I got them all.
And then when I graph it, do you see it?
Yeah.
Okay, good news is your information should still be there in the calculator tomorrow. We'll pick up this awkward spot tomorrow. What shape do you think you're seeing?
It's linear. I know that. Just
What?
kidding.
I don't see linear.
What are you talking about?
Linear's a line.
Oh. What was that?
Not linear.
That does not look linear to me.
Okay,
That
guys.
is curved.
It
So,
looks like a curve. What kind of curves do we often talk about?
The curved kind.
the ones that go up.
The curved.
Yeah, I'm trying to think if anyone said it.
It's not linear.
It is going to be a